I have a fairly simple design this week. I have a few ideas for 3D prints that would use an LED tea light rather than having to make my own lighting. So to get started, I want to create an LED tea light in CAD based on measurement of some that I already have, just so I can sanity check the designs and see what they will look like. Just a quick note before I start. I'm using FreeCAD version 0.21, the latest stable release. If you haven't updated yet, I highly recommend it. So let's get to it. As usual, I'm going to be doing this in the part workbench. It's perfectly possible to do it within the part design workbench. I just personally prefer the part workbench. Start with a sketch on the XY plane. Create a circle centered on the origin and set the diameter of 38 millimeters as measured from the existing tea light. Extrude that sketch to 14 millimeters, also as measured. The tea light has a gentle dome on the top, which I'm going to model as a revolve. So create another sketch, this time on the XZ plane. Since the dome sits on top of the existing base, I'll bring in the top as external geometry. Note that even though the external geometry I'm pulling in is actually a circle, as far as the sketcher is concerned, it's a line. It's a line because that's what's projected into the plane of the sketch. Fortunately, a line is exactly what we need. So I'll turn on cross-section view just so I can see everything clearly. Now using the multi-line tool, I'll start with a line attached to the y-axis, bring it down and attach it to our external geometry. And now I'll bring it out towards the perimeter of the base. I've measured the diameter of the dome at 21 millimeters, so I'll just set a horizontal constraint on the horizontal line. But of course the horizontal line represents a radius, not the diameter, since we're doing a revolve. So I need to divide it by 2, so 10.5 millimeters. The dome is 2 millimeters high, so I'll set that on our vertical line. Now to form the dome itself, I'm going to create an arc with 3 points to close the shape. There's no need to get the radius of the arc anything like accurate, it just needs to be in the right direction for now. It'll be corrected in the next step. Now because the top of the dome will be tangent to a horizontal line, it should be perpendicular to the vertical. So select the vertical line and the arc and set a perpendicular constraint. Notice how doing that also forces the correct curvature of the arc, as that is the only geometric solution to the constraints given. Now close the sketch, make sure it's selected, and click the Revolve tool. The defaults are already correct. It assumes a 360-degree revolve, and it's already chosen the correct axis. Looks good. Next, the tea light has a small lip at the bottom so it can sit level on a flat surface with clearance for the slider switch in the battery cover. So select the bottom of the base and create a sub-object shape binder. Just a reminder, the sub-object shape binder is actually part of the part design workbench, but I've made it available in part with a custom toolbar. Now select the binder, and in the data pane I'll set the offset to -2 millimeters. Select the binder again and extrude it 2 millimeters. Obviously it's not extruding in the desired direction, so select the extrude and in the data pane set reverse to true. Now I can select the base and select the extrusion and do a Boolean cut. On review it looks like we only want to pocket the bottom to 1 millimeter, so I'll just open the cut, select the extrude, and in the data pane, change the length to 1 millimeter. Finally, I'm going to need to model the flame. A flame is very much an organic shape. This is another case where we can get FreeCAD itself to do much of the work for us. I'm going to start with a few sketches to more or less outline the shape of the flame. Since the flame will be on the top of the tea light, I'm going to attach the sketch to the flat face of the base. It might be tempting to attach it to the dome itself, but because the dome is curved, that's unlikely to do what we want. So I select the top and create a new sketch and select Flat Face. Turn on the cross-section view so I can see what I'm doing and create a circle centered on the origin. I took a few measurements from the original T-light, so I know that a diameter of about 7 millimeters will do us nicely. Close the sketch. Since the first sketch is on the flat face of the top, I know I'm going to need to offset the entire flame by some amount to get it into the correct position. Right now, the base of the flame is inside the dome. To make moving things easier later, I'm going to create the second sketch attached to the first sketch. That way, moving the base of the flame can move the entire flame at once. So in the second sketch, I'm going to create another circle, also centered on the origin. This time set the diameter to 8 millimeters. Now yet another sketch also attached to the base of the flame. Another circle, and set this one to 10 millimeters. Once again another sketch, another circle. Finally set the diameter of this one to 1 millimeter. This will be the tip of the flame. So now I come back to the base and set the Z position to 2 millimeters and get the sketch up over the top of the dome. Now that I can see all of the sketches, I can start applying some Z offsets. Second sketch offset of 6 millimeters. Next sketch offset of 10 millimeters. Last sketch offset of 16 millimeters. Now that I can see them all stacked up, I have to say that this third sketch looks like the diameter is much too big. So I'll open up sketch 004 and change the diameter of the circle to 6 millimeters. Close the sketch, and that looks a lot more like it. Well, now we have a series of sketches outlining a shape, so the natural next move is to create a loft. Select the base sketch and I'll create the loft. Add each of the sketches in order from bottom to top. Check the Create Solid box and we have the beginning of the flame shape. It looks pretty good except for the fact that it's more of a nose cone than it is a flame. This is the part where we make CAD do some of the work for us. Select the third sketch, which strangely enough is sketch 004, and looking at the guide in the corner, I see that I want to offset it along the x-axis, just so that they're not stacked up perfectly straight. Just -1 millimeter, and already that's starting to look a lot more organic. I'll move the second sketch, sketch 003, +1 millimeter along the x-axis. And what once looked more like a nose cone now looks like a nice organic candle flame. All of this based on the mathematics built into CAD that help it to conform a surface to the constraints provided by sketches. But we have to remember this is a 3D object. We can see all the way around it. So while the flame has a nice organic curve on this plane, I'm going to turn it 90 degrees, and it's a little bit organic still because of the bending on the other plane, but it's straight up and down in a way that candle flames rarely are when there's breeze. Select sketch 004 and displace it on the y-axis by 1 millimeter. That puts enough curve on it in enough different planes that we get an organic looking flame whatever angle we look at it. I think that looks pretty good, especially for someone with no artistic talent whatsoever. Final step, I'm going to zoom in really close and you can see we have this little gap between the base of the flame and the top of the dome. This is to be expected. We've made it a flat surface to a curved surface. Something has to give. A very easy way to solve this is to go into the base sketch, and I'll reduce the Z offset from 2 mm to 1 mm. Because the other sketches are attached to the first one, the whole flame moves together. That puts the base of the flame just far enough inside the dome that we have no gap. Now it's just a matter of wrapping things up. The first thing I'm going to do is select the revolve and the cut. Fuse them together and rename the fusion to base. Next, rename the loft as flame. And finally, select the flame and the base and fuse those together. Rename that fusion T-Light. Now we can do whatever we need to with it. We can export it as a step file, or we can link it to another document and use it directly. Or even make a macro to animate the flame. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.